So we saw that we face a dilemma. We have this bifurcation. We have to keep one of the two weak separabilities because of tractability reasons, which may be a bit problematic. We have to give up one of the other weak separabilities, which may also be problematic. So we have to some problems to minimize or live with. Then it's good to have diagnostic tools to see where the problems are and where they are more or less serious, and also to see remedies, how we can reduce the problems. I'll discuss those things from now on. So the $1,000,000 question, which separability is best to keep and which better to give up? In general, other things equal, separability is most convincing for risky decisions. And second, a bit less, but also not still quite for ambiguous, uncertain events. And the reason is that events in decision on uncertainty, they are mutually exclusive. They can never happen. If one happens, the other doesn't happen. So there can be no physical interaction between them. If there are interactions going on, it can only be in the psychological mind of the decision maker. And I, as a Bayesian effect, think that it is irrational. So surely for normative purposes, this is very convincing, I think, but also empirically, it's quite, those are best usually. Then, after that comes welfare. Welfare, there can be, you can see how much money your neighbor is getting. So then it's already more plausible that interactions occur between different people. Even less convincing is intertemporal, because then interaction between your present self and your next month self, they have the same bank account, fudging of money. So there it is even less convincing. So this is in general the situation. And in particular, many papers study the combination of risk and time. And there was a presentation paper by Matthias Weber and also a paper by Kistner-Rode and Xiao Yu, where they used a framing. So they had the situation of risk and time. They used a framing that enhances intertemporal separability. Still, they found empirically that this risk separability was more prevailing. So that gives quite strong arguments that risk separability is more convincing than intertemporal. And I already talked about this paper by de Janet, Dillenberger, Otto Lever, and Gottlieb, I think, where also they argued, based on theoretical views, which I agree with, that they choose for risk separability, not for intertemporal separability. So risk first aggregation, because they find it more convincing. So those views go around in the literature. Then attributes are somewhere in between, depends entirely on the attributes. Some attributes, it's quite plausible to treat them as separable, but maybe economists know about competing and completing goods where there is interaction going on. So it depends entirely on what the attributes are. So this is one thing. Then if you want to, sometimes maybe you want to manipulate, maybe in an experiment, you want subjects to perceive one of the two, to more do risk first aggregation, or maybe time first aggregation rather than risk first, or whatever it is. Then there are you can frame your stimuli in such a way to enhance that. This can also be in policy, if you want to have to divide ice creams over your children. If you formulate it one way or the other, that can help subjects, people, to have more of one or other perception in the order of aggregation. For instance, if time and risk are involved, as in the example we started with, then if you say, if you formulate it like this, at each state you receive an outcome stream, then you enhance row monotonicity, that people take the states as separable. That formulation tries to make people think that way. Or if you depict things in this manner, first you display the states and only then the time points. This figure also quite enhances people to do risk separability rather than time separability. I have seen studies in welfare and fairness, experimental studies, where people deliberately chose such figures to enhance the kind of separability and tested experimentally if it worked. So those are things that can be done to enhance it in experiments, or maybe in policy management, children, whatever it is. Two other remedies that I would say less about. One is the timing remedy. That is, especially when you have uncertainty playing a role, then you can manipulate or observe the timing of the resolution of uncertainty, and that can play a role. Now, I should explain something to avoid misunderstanding that I didn't explain yet, but that is quite crucial, that in all this lecture, all this paper, I assume only one time decision. I assume at time zero, the present, the decision is made and that's it. Dynamic decision principles never play a role in this analysis, just to keep things simple. It's only perception discounting of outcomes that did play a role, but not dynamic decision principles. And in particular, we can sometimes assume that if uncertainty if it plays a role, that the uncertainty was resolved before the decision was taken, maybe before time point t0. But then we assume that the subject or the decision maker, the agent, knows that the uncertainty was resolved, but doesn't know what the uncertainty is. So it is still uncertainty. So the information and the strategic relevance, in fact, rationally speaking, even play no role. It's only perception of resolution of uncertainty. Maybe they tell you the coin, the flip will decide. It was already flipped before you took your decision, but you don't know what the result of that flip was. Such things, that kind of manipulation is the only kind of manipulation that I consider. No strategic relevance. So that can be used, and indeed some in welfare evaluations. This is with the children ice cream. You say, well, we did a lottery. You had the same chance, or to make policies more acceptable, or maybe in the Anscombe-Alman framework to make horse monotonicity more acceptable. You can say first the horse race took place. We first inform you which horse wins the race, and only after that we carry out the lottery to give you money. That can help to encourage, to stimulate horse monotonicity, which is the standard assumption in Anscombe-Alman framework. Another thing that can help is provide only partial information. For instance, let's again consider the Anscombe-Alman framework. If you tell subject which horse wins the race, then you tell your subject, okay, let's assume in an experiment, what the lottery will give conditional on that horse winning. And you don't tell them for the horses that did not win what the lotteries would have given them. Then subjects cannot know about correlation, for instance. And that can also be used to enhance horse monotonicity, which is the thing that is needed for the Anscombe-Alman framework. Today we discussed quite more. I have no time here. We give an example where this horse monotonicity is problematic, but where you are using correlation. Then if you avoid using the correlation, you can avoid that counterexample. But we started to explain that you avoid the symptom, not the disease, which is that separability of horses is still not very convincing. So there's much more to discuss, but I don't want to take very much time for that anymore. So these are the ways in which you can manipulate maybe or make diagnosis of what is happening. Let me now go to further application. Only one, don't take very much time, only one application I'll elaborate a bit on. The random incentive system. That's yet another example where you optimize maybe over choice option in a choice situation, but also over a choice situation in an experiment. That's just two components. All the theory applies just as well. All these I'll illustrate it. I'll do it for the special case where you do an experiment to measure ambiguity attitude, and where there is something that people call hedging may or may not play a role. And again, that's just one other example of a $1 million question. All fields are discussing the same issue: welfare, ex post, ex ante fairness, the random incentive system. Is it valid or not? Well, do you do the random choice of the real choice situation before or after the experiment? All these discussions amount to the same general question of the $1 million question. But now let me give you details how it goes. So imagine an experiment. Let's say it's an experiment. A coin will be flipped heads or tails, but there's also an ambiguous urn. A ball will be drawn from it, red or black, and you don't know the composition of the urn. It's the unknown two-color Ellsberg urn. So there it is, an ambiguous urn, unknown composition. Now imagine in an experiment, in the first choice situation, we observe that the subjects can choose between 100 and €1 if the ambiguous ball is black, or €100 if heads comes up. The subject prefers this ambiguous 101 outcome. So this suggests that this subject is either ambiguity seeking or ambiguity neutral, or maybe a very little bit ambiguity averse, but surely not very ambiguity averse. €1 is already enough for this subject to take the ambiguity. Imagine in choice situation 2 in the experiment. There were only two choice situations in this experiment. In choice situation 2, the other ambiguous color, the subject also prefers to gamble on that rather than on tails of the coin. We observe these two preferences. Again, that may suggest that the subject is, if it is at all ambiguity averse, then it is not very close to neutrality or maybe even ambiguity seeking. Now, Let's assume that this experiment, real incentives are done using the random incentive system. One of these two choice situations is chosen randomly and implemented. So can we now conclude what I just said about almost no ambiguity aversion? There have been people who said, no, you cannot. There is a confounding phenomenon, they call it hedging. And I'll explain the reasoning. So here I put up what happened in the experiment. Let's see, here were the two choice situations. And the subject preferred this to this and that to that. That means this combination of choices in the experiment, here a matrix is a strategy in the experiment, describing for every choice situation what you do, is preferred to the subject by the subject to this strategy, this combination of choices in the choice situation in the experiments. So two behaviors in the experiment, one is clearly preferred by the subject to the other, because here, over here, this is the 101 under the color for black. This is the 101 under the red, and that's preferred to the two 50-50 lotteries. So indeed, this was what we observed in the experiment. Now the hatching reasoning goes, well, we have here a matrix again. So the $1 million question, row first or column first, row monotonicity or column monotonicity. Now there have been people, the hedging argument says, let us look at the columns. Let us look at the combination of the draw of the ball and the toss of the coin. There are four combinations possible. They are depicted as the columns. And to the left, whatever is happening with the color drawn from the urn and the toss of the coin, you are getting, because of the random incentive system, 50-50 whether choice situation S1 or choice situation S2 will be implemented. That means in this experiment, in the left, you are getting a 50-50 lottery, 101 and 0. It's independent of what happens with the color drawn from the urn and also the coin toss. It says 50-50, 101 or 0. On the right-hand side, similar story. It is no matter what the uncertainties in the experiment, because of the random incentive system, it's just 50-50, 100 or 0. So the left option is simply stochastically dominating the right option. And therefore, what you observed in the experiment was simply generated by stochastic dominance, having nothing to do with ambiguity. And therefore, you cannot infer anything about the ambiguity attitude in this experiment because of the confounding of hedging. And here it is said that the second choice situation provides a hedge against the ambiguity of the first choice situation. But it will be quite clear, I hope, after this all these things I said, that this reasoning is assuming column monotonicity. And the random, if we do row monotonicity, then the random experiment is fully valid. Then the choice situation S1 is taken as separable, and then the choice means you prefer this gamble to that gamble. That's a genuine preference. If you do row first monotonicity, the second preference is also valid, and then you can conclude that indeed the subject is either not or only very little ambiguity averse. So here we see the validity of the random incentive system. It depends entirely on the $1 million question: is row separability more convincing or column separability? Now there have been two papers by Bayon, Halafi, and Chen Li, where they did test this. They did everything they could, the framing, how they put all the choice situations on one same page, they tell the subjects, they point out to them, they did everything they could to enhance the perception of column monotonicity, so to enhance the hedging phenomenon. Then they found indeed hedging is taking place. So then they show that in principle it can happen that hedging is invalidating such an ambiguity experiment. However, that was their deliberate purpose. But I think in general, this doesn't happen in most experiments. This doesn't happen. Almost every experiment, every choice situation is on a different page, for instance, a different screen. The first choice situation, the subject doesn't even know what the next choice situations are. Later choice situations, the subject cannot remember what the choice situations were that happened before in the experiment. So this column separability, where you are combining all the strategies in the experiment, is in general, I think, really implausible. It's much more plausible in the regular experiment with the random incentive system that you have row separability, which means that the random incentive system, I think, usually works quite well. Of course, not perfect, but in a way, it's the best we have right now. Anyway, this shows you again another example, and also for other things than hedging ambiguity, in general, the validity of the random incentive system, you can formulate it this way. And it's one other example of a $1 million question, row first or column first. There have been many other discussions, many other fields going on, and our remedies can be applied similarly in all these fields. So one of the purposes of this presentation and the paper is to unify all these people in welfare, fairness. They're discussing the same thing as people in validity of random incentive system. So to unify all these things so that people can benefit from each other's views. That is one of the purposes of our paper. But such situation and discussion of the random system in general is going on. So many people have argued that determining the uncertainty about what the real choice situation is better to make the subject perceive that this happened before the experiment than after. Then you enhance that the subject is conditioning on the real choice situation, which is what makes it valid. So that is this timing remedy. And there have been several papers arguing that, testing that. And equality and welfare, same ex ante exposed, many experiments testing. And again, it's another example of $1 million question. A correlation preference in intertemporal choice. Again, here the timing of the resolution of uncertainty plays a big role. Would you like to combine for correlation? You may like to combine good with good, or maybe you could like to combine good with bad. That cannot happen if there's row first. Similarly, multivariate risk aversion is the same question, but for more general attributes rather than only time. The monotonicity condition in Anscombe-Ullman framework I've already discussed a lot. And again, it's an example of a $1 million question. Same thing happens, in fact, in the popular smooth model of ambiguity. Here there are also two stages. Then the events that capture the uncertainty about subjective beliefs, the second order events, they are treated monotonicity or separability of those events is assumed. But it's a bit problematic. Maybe risk savage events are more suited to have separability than those weird second order, a bit strange gambling on your subjective probability. Anyway, in many fields these things are going on, and our paper hopes to contribute and unify all of them. And then conclusion, I can say, beware of monotonicity, watch out for it, because it's a much more dangerous condition, much more problematic condition than maybe people have sometimes been aware of. I hope that this lecture and the paper that will come will make this thing very clear. So that's the end.